Good morning, children. You are welcome for the next episode from electricity. The important points you want to remember from this unit. First of all, what is electric current? It is the rate of flow of charges. Rate of flow of charges means it is the charge flowing in unit time. So the equation for it is I is equal to Q by T. Then another equation also you want to remember, that means potential difference V is equal to W by Q. V is the potential difference and W is the work done to move a charge Q. So V is equal to W by Q is the another equation you want to remember to solve some problems which is given in the exercise. Then another equation to find the current, I is equal to V by R. This equation we got from Ohm's law. That means current proportional to a potential difference, or I is equal to V by R. Here R is the resistance of the conductor through which current flows. And then you want to remember another equation to solve problem. That is total resistance in the circuit. Otherwise, effective resistance R is equal to R1 plus R2 plus R3 if there are three resistors of resistance R1, R2 and R3. Then this equation we got when they are connected in series. That means the resistors are connected in series. Now, if the resistors are connected in parallel, if the given resistors are connected in parallel, then the effective resistance in the circuit or total resistance due to these resistors we got from this relation 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, where R1, R2 and R3 are the resistance of the resistors connected in the circuit parallel. Then another equation you want to remember this one. This we got from Joule's law of heating. That means heat produced in a circuit when current flows through a resistor is equal to the product of the square of current, resistance and time in which that current flows. So it is equal to I square RT. Another equation also we got from this relation by using Ohm's law. That is V square T by R. By using this we can find out the heat producing. And another equation that we can use H is equal to VIT. Then one more relation is that H is equal to P into T. That means heat produced, otherwise work done. Heat produced or work done, H is equal to P into T. Then one more relations that is related to power. P is equal to VI. That means power is the work done in unit time. And another relation can use to find power P is equal to V square by R. One more relation there is to calculate power P is equal to I square R. Here power we know it is work done or work done in unit time or energy consumed by an appliance or energy used by an appliance or gadget in unit time. Its unit we know what is kilowatt hour is the usual unit of calculating commercial unit of electric power. The unit of power is watt, but it is very small, so we use kilowatt hour. Now, by using these relations, we want to find out answer to the given questions in our text. In our previous class, we discussed about question number up to the question number 11 in the given exercise. Now we are going to discuss about question number 12. Several electric bulbs designed to be used on a 220 volt electric supply line. That means electric supply line of 220 volt. Electric supply line of how much? 220 volt are rated 10 watt. That one is rated as 10 watt. How many lamps can be connected in parallel with each other across two wires of 220 volt line if the maximum current available is 5 ampere? See, in an electric supply line, there are 220 volt potential, and we connected number of 10 watt electric bulbs, and the current through now the circuit can be 5 ampere. Then we want to find out how many 10 watt bulbs one connect in order to adjust current in the circuit is 5 ampere. Here you see, we know potential and the current, so the resistance we know R is equal to potential by current. Now R is equal to V by I. V is 220 volt by current is 5. By cancelling this 22 and 5, we know 4 times 5 20, so 4, balance 2 and this 0 20, and again 4. That means in the circuit, resistance 44 ohm. To get this 44 ohm resistance, we want to know how many resistors should be connected, or how many 10 watt bulbs should be connected in parallel. First of all, we can find resistance of this 10 watt. That means we know this is power of that 10 watt, and to that also applied 220 volt. We know resistance R is equal to, that means from this relation P is equal to V square by R. R is equal to V square by P. That is V square is equal to 220 into 220 divided by P, 10 watt. This will come. 220 into 22 is the resistance of the circuit, given by one 10 watt bulb. Then we want to connect a number of 10 watt bulbs in order to get 44 ohm. So to get 44 ohm, we want to connect how many these cells. See, here effective resistance is given as 44. We know 1 by R is equal to 1 by R is the effective resistance when number of resistors connected in parallel. 1 by R is equal to, we are going to connect N such this N by this we can take as R dash, it is better. This R dash is the resistance. So 1 by R is equal to N by R dash. R dash is the resistance of one of the R dash is the resistance of one of the 10 watt bulb. From this 1 by R is equal to N by R dash. That is 1 by R, that is given 44. That is effective resistance is 44. That is equal to N, number of 10 watt bulbs we are going to connect it. And R dash is the resistance of one such bulb. So R dash here we got, that is 220 into 22. 220 into 22. See, we can simplify this again. Then what we will get? From this to get N, we can cross multiply this one. So N is equal to this 220 into 22 will come up, and this 44 now in down. We know this 22 2 times is 44. So this 22 one time here 2 times. Again this 220 divided by 2. How much it will come? N is equal to, that is here 1 0 times. So 110. That is N is equal to 110. It means we want to connect 110 10 watt bulb in parallel to the circuit, so that current through the circuit is how much? 5 ampere. How many? 110 10 watt bulbs we want to connect in the circuit in parallel to get current in the circuit as a 10. Current in the circuit as 5 ampere. See, now I hope you got idea about this one. Now we can go to next question. Question number 13. A hot plate of an electric oven connected to 220 volt line. A hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B, each of 24 ohm resistance. That means plate A, how much is its resistance? 24 ohm. Plate B, its resistance is how much? That also 24 ohm. Which may be used separately in series or in parallel. That we can use in series or parallel. What are the currents in these cases? That means which may be used separately in series or in parallel. What are the currents? We want to find out the current in that cases. See, if the resistors separately, if we use at first in series, that means the plates A and B connected in series. Then the total resistance R is equal to R1 plus R2. That means from this relation R is equal to R1 plus R2. Then current R is equal to find the current, we are going to find the total resistance at first. See, R is equal to 24 plus plus 24, that is equal to 48 ohm. 48 ohm. Now we applied a potential difference of 220. We applied a potential difference of 220, so the current I is equal to V by R. It is equal to V, how much? 220 divided by 48. We can cancel at first with 4. See, 5 times 4, that is 5 times 4 is 20. Then again 2 answer, 55. Here 4, how many times? 1 and 2. That means here 1 times 4, 4 and 2 times 4 is 8. Here in 20, how many times 4? That means 5 times 55. Now we want to divide this 55 with 12. 12 times 4 is 48. 48. Balance, how much it will come? 55 minus 5, from 5, 8 when we subtract, this become 15, from this 15 that will come 7. 70. How much it will be? In 70, 10 times 6 is 6, and in 70, how many times it will come? That means when we divide this 12 with 4 times, that is 4 point, and this will come 5. 12 times 5, 60, balance 10. 8 times 96. So this answer is 4.58 ampere. When the resistors are connected in series, current through them is 4.58 ampere. Now we are going to connect these resistors in. Now we are going to connect these resistors in parallel. When the resistors connected, that is 1 by R is equal to 1 by R1, that is 24, plus 1 by R2, that is also 24. 1 by R is equal to, that means denominator 24, 24 common. So we can add in numerator 1 plus 1, 2. So R is equal to, taking reciprocal, 24 by 2, that is equal to 12. Now R is equal to 24 by 2, that is equal to 12 ampere is the current through the circuit. Current through the circuit is now, resistance, effective resistance in the circuit is 12 ohm. Here R is equal 1 by R is equal to 2 by 24, or R is equal to 24 by 2, that is equal to 12 ohm is the effective resistance, not the current. Effective resistance now in the circuit is 12 ohm. Now we want to find out the total current through the circuit. See, current I is equal to V by R. V 220 divided by R. R is equal to, here how much is R? 12. See, 220 15 by 12. Now we can divide. We can cancel some with the 2 times 6. 6 it will come here 11. Again we can cancel with the 2. Here how much is 3? Here 55. Once again, that means in 220. We can cancel with the 2. This total also cancel with the 2. Here what we get is 6 and 110. Again we can divide these 2 with the 2. So it will come 55. Here 3. So 55 by 3. 55 by 3, that is equal to 1 times 3, 2, 25. How many times? 8 times 3, 24. Then on 0. In 0, that is after giving decimal, we can put 0 here. Then how many times? 3, that will repeat. So total current when they are connected, in parallel, total current when they are connected in parallel, I is equal to V by R, that is equal to how much? 18.33 ampere. This is the total current. Now we want to find current through each of the resistor. Both the resistors of the same resistance. So this total resistance we got as how much? Total resistance 12 ohm, and the total current is 18.33 ampere. This total current splits into 2 equal parts because current through each of the resistor will be equal because of their resistance are equal. So current through each resistor, that is C. This is the answer for B, and answer for C. Current through each of the resistor when they are in parallel, that is equal to how much? I that can be taken as I dash is equal to 18.33 divided by 2. That is how much? 9.165. This much ampere is the current through each of the resistor of resistance 24 ohm. Now the answer to this question, once again, what are the things that given in this problem? 2 plates A and B of resistance 24 ohm each. At first we connected them in series and total resistance we calculated. Then current we can calculate it by using the relation I is equal to V by R. Then the 2 resistors connected in parallel. That is 24 and another 24. That is 1 by R is equal to 1 by R1. Instead of R1 we can put here 24, and here it is R2. Here it is 24. From that total resistance we got as 12 ohm when they are in parallel. So we are going to calculate current. In that case, I is equal to V by R, that is 220 by 12. From that we got how much current is 18.33 ampere. Current is flowing through the circuit. Then third question, current through each of the resistor. We know when the resistors are in parallel, current through them will become V by R. There R is the resistance of each of them, because potential difference there will be the same. So I dash is equal to 18 point, the total current split into 2 because resistance of these two are equal. So 18.33 current get split into two equal parts. So it will come 9.1654 each of these. That means 18 two times in this 3 1 and 103 6 times and balance 5, that is 5. Okay, now we can go to next question. Question number 14th one. Compare the power used in 2 ohm resistor in each of the following circuit. First, that means we want to compare power used in 2 ohm resistor. 2 ohm resistor. We want to find out the power. In the following circuits, at first 6 volt battery, 6 volt battery in series with 1 and 2 ohm. 1 ohm and 2 ohm. We know when the resistors are connected in series, total resistance R is equal to R1 plus R2. That is 1 plus 2, that is 3 ohm. Current through this 1 ohm and 3 ohm will be the same. Current through this 1 ohm and 3 ohm will be the same. So current I is equal to V by R, that is equal to 6 volt by 3, that is equal to 2 ampere. This is the current. Now what we find means we want to find the power across 2 ohm. Power across 2 ohm means current through this 1 ohm and 2 ohm will be the same. So power P is equal to, we can calculate by using VI. That is the potential across 1 ohm is not the same as that the potential across 2 ohm. So power we can use VI, but see here V potential is not the same. This 6 volt is not across this one and also not this. But we know current and resistance, if we know, that means by using this relation we can calculate the power. That means so instead of V we can use IR. So this relation here we can use I square R. I is here 2, so 2 square and potential power across 2 ohm. So resistance 2. 2 square is 4 and 2 8 watt ohm. So power across this one is 8 watt. Power across 2 ohm resistor is 8 watt. How we got this result? At first we calculated current, that we know current is 2 ampere, and if we know current and resistance we can calculate power. Now second case they are given, there are 4 volt battery, 4 volt battery in parallel with 12 ohm and 2 ohm. 12 ohm and 2 ohm. Here also we want to calculate power across 2 ohm. We know power here given potential as 4 volt. Another resistor 12 ohm and 2 ohm. When the resistors are connected in parallel, potential across each of them will be the same. So here potential is 4 volt across 2 pole. So power we can calculate by using the relation power V is equal to V into I or VI. That is V is 4 and power P is equal to V into I, but here current is not here given, but we can use here voltage and resistance. We can use this relation, we can use it is better use this relation instead of this, otherwise we want to find out P is, that means V is equal to, we can use this relation because V is there and also R is there. So V square by R. V is 4. So 4 into 4 divided by R2. This 2 and 4 we can cancel 2. That is power is equal to 8 watt. Power here is equal to 8 watt. That means in these two cases, power across 2 ohm is 8 watt. Power across 2 ohm is 8 watt itself. Now we can move to the next question, question number 15. See, 2 lamps rated 100 watt, 220 volt. And another one is 60 watt and 220 volt. Are connected in parallel. 2 lamps, one rated as 100 watt, 220 volt. Another one is 60 watt and 220 volt. Connected to the circuit in parallel to electric mains. What current is drawn from the line if the supply voltage is 220? Supply voltage is 220. We know current I is equal to, from this relation P is equal to VI or I is equal to what will come P by V. P by V, from this relation P is equal to VI, so I is equal to P by V. Here 100 divided by V, 220. Then we can cancel with the 2 also. That will get how much? 5 by 11. We can divide in 5. How many times? We cannot take putting decimal 54. That means 11 times 4, 44. How much is 6? 0. 11 times 5, 55. How much? 5. That means 11 times 5 is 55. Then 5 R is 0, 4. So it will come as 0.454 ampere. This is the current. Next, we want to find out what potential is given 220 and power 60. So second current, this first current we can put as I1. So second current I2 is equal to P. That is 60 by how much? 60 by 220. We can cancel. Then again cancel. What will get with the 2? 3 by 11. Putting 30. How many times? 11 times 2. 22. Then 8. 11 times how much it will come? This will come as in 80, how many times it will come? 11 times 7 is 77. Balance 3, 30. 11 times 2. So I2 is equal to how much? 0.272 ampere. So total current now in the circuit I is equal to I1 plus I2. That is I1 is 0.454 plus I2 is 0.272. We can add this to how much it will come? 0. By adding 0.454 and 0.272. 7 plus 5, 12, 7. So the current is 0.726 ampere. This is the current in the circuit. This is the current in the circuit. Now question number 16 on. Which uses more energy? 250 watt TV or within 1 hour, or 120 watt 1200 watt toaster for 10 minutes. Which uses more energy? A 250 watt TV or that works for 1 hour and 1200 watt toaster about 10 minutes. First of all, we can calculate energy that is used by the TV. That is energy used by the TV, that is H is equal to, we can use P into T. That is P is how much? 250 into 1 hour. That means 60 into 16. So we can multiply 250, 25 is 60. That means we can keep the 0 here. That means 25 times this one is 150 and again with the 6. That means 6 times 0, 0, 9. Then here 1, 2, 3 zeros. This much unit is the energy consumed when the bulb is connected in, when the device is connected in the circuit or that works for 1 hour. Then we want to calculate about this toaster. That is energy consumed by the toaster in 10 minutes. That is H is equal to P into T. That is power is 1200 into time 10 minutes. 10 minutes we can change into second. So we know what is 12 times 6, 72. Then putting this 2, 0, again 2. How much is it coming? 72,000 joule. Sorry, 7,20,000 joule energy is using by the toaster. But here 9 lakh joule is using by the TV. So among these, which one is using more energy means which one is using more energy? Here TV is using more energy when it works for 1 hour and its power is 250 watt. And the toaster, its power is 1200 watt and it works for 10 minutes. Now I hope how to calculate this problem.